Alrighty, gang. Right now we're going to be taking a look at our lesson over fraction concepts, lesson number 2, which is over factors. So this is a really good time for us to review our multiplication facts, and we'll figure out why in just a second. So today the two ALEKS concepts that we'll be looking at are factors and prime numbers. So first of all, we need to review some definition words. What is a factor? A factor, we can say mathematically, a factor multiplied by a factor equals a product. So factor times factor equals product. You need to write this in on your notes packet. Factor times a factor equals a product. So the answer to a multiplication problem is a product. In an English way, like in a sentence way, we could say a number. What operation are we doing? We're multiplying. So a number multiplied by another number. So you need to write in multiplied in your notes packet. So when we talk about factors and numbers being able to be multiplied by each other, we have a composite number if it can be divided evenly by numbers other than 1 or itself. So you need to write in evenly in your notes packet here. Composite numbers mean I can be divided evenly, so no remainders, by numbers other than itself in 1. So a lot of numbers that we deal with are composite numbers. But we also have a prime number. A prime number is divisible by exactly 2 numbers. What 2 numbers do you think those are going to be? Think about that for just a second. Take a guess. Exactly 2 numbers. You got it. 1 and itself. So that's a prime number. Interesting fact. What do you think the only even prime number is? The only even prime number. If you said 2, you win. 2 is the only even prime number. That's a bit of trivia that might come in handy. Okay, now that we should have all of our notes filled in here, let's take a look at some example problems. So things that we're going to have to do, we're going to have to write down all of our factors. So I get a purple pen, perfect. We're going to make a list of the factors using divisibility rules of the following numbers. So remember yesterday when we did divisibility rules? So what do I know 25 is automatically divisible by? A 5, because it's there. The first thing it's always divisible by is 1 in itself. So I write those in first. And then by my divisibility rules, I know that 25 is also divisible by 5. And it's not divisible by anything else. So my factors are 1, 5, 25. When I start repeating numbers, I know that I'm done. All right, so let's take a look at 72. Again, I know that 1 and 72 have to be factors. So now let's take a look at our divisibility rules. When I add up my digits, I get a 9. It's an even number, so I know it's divisible by 2. So I need to know 2 times what is 72. You know what I'm going to need to do? I'm going to need to make this. Oh. I need to make this bigger. So we've got 72. 2 times 36 is 72. I know that 3 is going to work because it adds up, but I need to know 3 times what? So I'm just going to do 72 divided by 3. So it looks like 3 times 24. How about 4? If the last 2 numbers are divisible by 4, so let's do 72 divided by 4. That works. 4 and 18. So my 2 factors of 72 are 4 times 18 equals 72. So I'm going to write in a 4 and an 18. 5 Nope, because it ends there. But 6 I know is going to be 1, because I automatically have 2 and 3, right? But I don't know that multiplication fact off the top of my head, so I'm going to have to do that longhand real fast. So that's going to be 7 minus 6 is 1. So 6 times 12 gives me 72. So that is my list of factors for 72. So again, we used our knowledge of our divisibility rules yesterday to know for sure that 72 is divided by 3. It's not a basic fact, so I went ahead out and did my problem over here. All right, let's look at 100. I know for sure I'm going to have 1 and 100. It's an even number, so I know it's going to be 2 and 50. How about 3? My digits add up to 1, so that's not going to work. How about 4? Is 4 going to work? Well, I know that there's 4 quarters in $1. So I know that's going to work. 1, 2, 4. How about a 5? It ends in a 0, right? So 5 times 20. There's 5 $20 bills. How about 6? No, because I don't have a 3. 7? No. 8? No. 9? No, because it adds up to 1. How about a 10? 10 times 10, and that should be it. So these are 1 times 100 gives me 100. 2 times 50 gives me 100. All of these are my factors of 100. Okay? Now you're going to do the 2 U-try problems. All right. Here are answers to our U-try problems. Factors of 27, 1 times 27, and 3 times 9. Factors of 88, 1 times 88, 2 times 44, 4 times 22, 8 times 11. So those are all of my factors. And I believe our next page, now we have 2 more problems, practice problems that are prime numbers. So is 7 a prime number? So I need to list out my factors to know if it's a prime number. A prime number means only 1 in itself. So 1 and 7, so that's a prime number. 12 has 1, 12, 3, 4. So I know it's not 20. It's an even number, so I know it's not. 21 has 7 times 3, 1 times 21. 23 is only 1 and 23, so it's prime. 26 is an even number, so it has to be not prime. You're going to go ahead and do the U-try problem, and I'll be back in just a second. Here are the answers to the U-try problem. 5 is a prime number, 11, 13, and 23 was on our last one, so 23 is a prime number. And that should bring us to our stamp page that we will do tomorrow, first thing at school, so we will see you then.